In the previous video, we learned how to solve quadratic equations using the factoring method, the square root method, and by using the quadratic formula. So with these next four problems, I'm not going to tell you which way to solve them, and we're going to go ahead and work through these and figure out which would be the best way to solve each of them. So we have to learn how to differentiate between the different methods to figure out which is the best. We can always use the quadratic formula, but often there's an easier way. If we can factor, we definitely want to factor. Square root method is normally an easier method. So it depends on the problem though. So let's look at number 16. So notice this one here, we've got that x squared, and there's also no x term, which is kind of a giveaway that you're going to want to use the square root method. In fact, if we could just move that 2, then we'd have x squared by itself, a number on the other side, and that's the setup that we want for the square root method. So let's go ahead and divide each side by 2. So we're going to get x squared is equal to 125. So now we can take the square root of both sides. Don't forget your plus or minus. And hopefully you're looking at that 125, square root of 125, and you can see that there's a perfect square factor there. In fact, if you look at the first four perfect squares, 25 is going to be a factor. And so this is 5 square roots of 5 when you simplify it. So our answer is x equals plus or minus 5 square roots of 5. So again, there's two answers here. Positive 5 square roots of 5 and negative 5 times the square root of 5. All right, let's look at number 17. Now in this problem, if this were a 0 over here, we could actually just set each of our factors equal to 0. But that property only works when you have a 0 on the one side and the other side's factored. So in this case, we're going to have to distribute, or not distribute, but FOIL out the left side and then move that 2. So let's go ahead and do that. So 2x times x is going to give me 2x squared. 2x times 1 is 2x. Our inner product is going to be minus 5x. And our last product is going to be a minus 5. And then let's go ahead and combine our like terms here. And let's get rid of the 2 by subtracting 2 on each side. And so we end up with 2x squared minus 3x minus 7 equals 0. So let's go ahead and see if we can factor this, because certainly it'd be nice if we could. So we need two numbers that multiply to negative 14, right? We're doing our a times c. And our b term is negative 3. So the factors of 14 are 1 and 14 and 2 and 7. And when we're going to need opposites, and since they need to add to a negative 3, let's make the bigger numbers negative. And you can see neither of these options are going to get us a negative 3 when we add. So in this case, we're going to want to go to the quadratic formula. This doesn't factor. So a is 2, b is negative 3, c is negative 7 here. I'm going to go ahead and make a shell here with the quadratic formula. Let's see, b is negative 3, and a is 2, and c is negative 7. Make sure you get all your numbers in the right place. So we're going to get 3 plus or minus. And when you simplify inside there, you got a 9 minus, you got to multiply a 4 times 2 times negative 7, which is negative 56. So that's 9 plus 56, which is 65. So this is just the square root of 65 over 4. And this one's kind of nice because if you look at 65, there are no perfect square factors, and there's nothing else we can simplify here, so we're done. Let's move on to number 18. This is another one where we're going to try to factor it, but nothing's going to work here. 29 times 1 is the only way to get 29. So we're back to the quadratic formula again. Let's make a shell, and let's plug in -4 for B, and 1 for A, and C for 29, or 29 for C. Okay, so again, make sure you have all your numbers in the right place. We're going to get x equals 4 plus or minus, let's see, this is going to be 16 minus 4 times 1 times 29, which you will find is 116. When we subtract 16 minus 116, we get -100. So this is just going to be the square root of -100, and that's all over 2. So don't forget, square root of 100, of course, is 10. Because of the negative under the square root, we're going to have a 10i. And you can see that this is going to simplify further. In fact, each of these terms, the 4, the 10i, the 2, they're all divisible by 2. I'm going to do this two ways. We can break this into two fractions, 4 over 2 plus or minus 10i over 2. Of course, 4 over 2 is 2, and 10i over 2 is 5i. Now, again, there's a shortcut you can take when all of your terms are divisible by a common factor. We can just divide all of those terms by 2, and this is the same answer. We don't need the 1 in the denominator. All right, let's move on to number 19. All right, so we've got some fractions to clear here. So notice we've got an x minus 3 as an algebraic factor in the denominator on that first fraction. And x minus 4 would be another algebraic factor. Now we don't really want to include another one if you look at the right side here. And in fact, you should always be suspicious that this will factor into the other two factors, the x minus 3 and the x minus 4. And sure enough, if you factor that, you will get x minus 3 times x minus 4. All right, so another thing that we want to remember is our restricted values. Notice in the first fraction, if your value of x is 3, 3 minus 3 is 0, and you would have 0 in the denominator of a fraction, which makes the expression undefined. So 3 is a restricted value, and the same thing with 4. Of course, 4 minus 4 in the second fraction would be a problem. So those are our restricted values. So I'm going to go ahead and rewrite this equation, and we're going to multiply each of the terms by our LCD. So again, if you're writing this, you can stop the video and just take it as slowly as you want. All right, so when we multiply the LCD times our first fraction here, the x minus 3's are going to cancel, and we're going to be left with 3 times x minus 4. And when you multiply times the LCD times the second fraction, the 5 over x minus 4, the x minus 4's are going to cancel. Notice I brought down that plus sign, and what's left is 5 times x minus 3. Now the nice thing on the other side, you can see both factors cancel, and so all that's left is the x squared minus 20. Now when you look at this equation and you see that x squared, you should be thinking this is a quadratic equation. And so with a quadratic equation, we want 0 on one side and everything else on the other side. Since my x squared is positive over here, I want to leave that there. Let's go ahead and distribute on the left and simplify, and then we'll get everything on the right side. So we're going to get 3x minus 12 plus 5x minus 15 is equal to x squared minus 20 when we distribute. Let's combine our like terms. We'll get 8x there. We've got a minus 12 and a minus 15. which is a minus 27. And we're almost there. Let's subtract 8x on both sides and add 27 on both sides. And we'll get the 0 we've been working towards on the left. And on the other side we have x squared. We don't have any other x squared terms. We have that minus 8x. Again, there's no other x term. But we can combine the minus 20 and the 27 to get a positive 7. And so we need two numbers that multiply to 7 and add to negative 8. So you'll find that negative 1 times negative 7 and negative 1 plus negative 7 is going to be the combination that works. Of course, factors of 7, you don't have to look very far. Now, because this is a 1 here, we know that we can just plug those numbers in, and you could verify by foiling that that is the correct factorization, which means our answers are 1 and 7. And I think I'm going to stop this video right here.